Hello everyone, Namaskara Karnataka. I hope you are doing very well, and today we will going to discuss 2 marker and 3 marker questions to get 70 out of 70. Recently we were discussing 5 marker questions, and today we will going to discuss 2 marker and 3 marker question. Okay, I hope audio and video is proper. If is there any problem, then let me know in the chat box. So just put a thumbs up, then after we will start the session. And if you are not subscribing the channel yet, just subscribe the channel and hit the bell icon along with the likes. So just share the session with your friends and join the session to get perfection of 2 marker and 3 marker question. So hello. Okay, it's fine. And you have any doubt regarding any question apart from this session, then also mention in the chat box. We will discuss that questions. All right. Okay. Some of the students putting their doubts yesterday, so I cover that questions also in this session, just because that question, so it's basically 2 marker or 3 marker questions. So we will discuss that questions in this session. All right. Hi Girish, hi Samuel, hi Shu, hi Ananya, hello Abhishek, hi, hello. Just okay, it's fine. Okay, it's fine. Everything is going good. Yeah, I'm doing each and one question. Don't worry, Abhishek. Yeah, numericals also. Okay. Okay, that's great. Then can we start the session? Just put a thumbs up. Then after we will start the session, and you wanted to achieve 70 out of 70, then just hit the like button up to 300. Like button up to 300. Okay. Yeah. Okay, fine. Let's start. Yeah, 3 markers numericals, 2 markers numericals also. 2 markers numericals also. Yes, that's great. Let's begin the session. Let's begin the questions from 2 markers. Right? These are the questions, 2 marker questions. Right? So, very first question. In a transistor, the base is lightly doped. Explain why. As you know, in transistor, base is lightly doped. Base is lightly doped just because we want a channel to carried out charges from emitter to collector, right? So that we lightly dope the base. Fine. An electrostatic field line is continuous curve that is held line cannot sudden breaks. Why not? And second one, explain 2 field lines never cross each other at any point. Right. So first question, an electrostatic field lines are continuous curve that is held line cannot sudden breaks. Why it's not? See, the tangent at a point on electric field line of force tells the direction of electric field charges from point to point. Therefore, the line of force are generally curved line. Further, they are continuous curves and cannot have sudden breaks. If it is so, it will indicate absence of electric field at that break point. See, as you know very well, if I'm considering here Q positive charge and here is Q negative charge, so electric field lines are just like this. And why this is curved? Curved line shows the direction of electric field. If I'm trying to draw tangent at any point, these tangent shows the electric field intensity at that point, right? But if is there any break point, see, if is there any break point, if electric field lines moving here and drop, then after like this, then what we observe, in this region there is no electric field, which is not possible, okay. 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 Now explain why two field lines are never cross. See, if two field lines are intersect at each other, see, if two field lines intersect each other, first field line and this one is the second field line, then at the common point, at this common point, we have two directions of electric field intensity, which is not possible. Electric field intensity at a point is unidirectional, only one direction that electric field intensity have, right? But if intersection, then there will be two directions of electric field intensity, which is not possible, right? See, the tangents at a point on the line of force gives the direction of electric field at that point. If two lines of forces intersect each other at a point, then electric field at that point will have two directions, as same cannot be true. Two force of lines will never intersect each other. Okay? Okay? Okay. Now, moving to third question. This is another very important question, right? See, a conducting loop is held above a current carrying wire PQ as shown in the figure. PQ is a current carrying conductor and the direction of current is from Q to P, right? Depict the direction of current induced in loop when the current in the wire PQ continuously increasing. See, if current increasing in the wire PQ, then due to this wire, there will be a magnetic field lines around this wire. See, magnetic field lines around this wire in just like this. And what is the direction of these magnetic field lines? See, what is the direction of these magnetic field lines? Direction of magnetic field lines is just outward. Magnetic fields just outward. So, induce current in loop in such a way to oppose this increment of the flux in the coil. See, the direction of current, according to Lenz, the direction of current in this loop in such a way which is opposes the cause, right? So, the direction is anti-clockwise. Induced current, the direction is anti-clockwise, right? If current is anti-clockwise, then it will oppose the change, right? Oppose the change, right? Okay. Now moving to next. A short bar magnet of magnetic moment 0.32 joules per Tesla is placed in a uniform magnetic field of 0.15 Tesla if the bar is free to rotate in the plane of the field. Which orientation would correspond to its first stable and second unstable? As you know, u which is equals to negative of mb sin theta, right? This is mb sin theta, and the stability deciding factor is this theta, or you can say this sin theta, right? This sin theta will decide is there stability or instability, right? So, see, a bar magnet is directly along the direction of external field, that is P E is minimum, u equals to negative of mb, that is 4.8 into 10 to the power minus 2 joule. This is the most stable case. And if any other position other than the above unstable, the one with maximum potential energy anti-parallel to that magnetic field, in this case u equals to mb, that is 4.8 into 10 to the power minus 2. Okay, see, so just see basically, as you know, just wait. Okay, figure 1.33 shows, right, This figure shows track of three charges particles in uniform electrostatic field. This is the uniform electrostatic field, right? Give the sign of three charges, first, second and third. Which particle has the highest charge to mass ratio? Highest charge to mass ratio. See, as per deviation, as you see, first charge and second charge, these charges are negative charge just because they are deviated towards to positive, and only the third charge deviated towards negative, so that this third charge is basically positive charge. This charge is basically positive charge, and these are negative charges. First and second are negative charges. So let me know the answer of this question in chat box. Just put an answer in chat box. Fast. Fast, very fast. I'm waiting for your answer. Okay. All questions are so much different. In questions we had simple. No, basically these questions are very much important, and these questions basically are frequently asked questions. These are frequently asked questions, right? Okay. So charge first and second are negative as they were attracted to the positive plate, and charge 3 is the positive, it deflects towards the negative plate, so that the third charge has the highest charge mass ratio. It would positive charge. Okay. Now moving to next, sixth question. 12 picofarad capacitor is connected to a 50 volt battery, right? Connected to a 50 volt battery. How much electrostatic energy is stored in the capacitor? U is equals to, as you know, U equals to half CV square. Just put U equals to half CV square. Just give me a minute. Just give me a minute. Yeah, you can put the values U equals to half CV square and get your answer. I think there is some technical issue. Yeah. Okay. Come to the question. That is C equals to 12 picofarad. C equals to 12 picofarad. I'm using this. C equals to 2 picofarad. That means 10 to the power minus 12, right? And V equals to 50 volt. U equals to half CV square. Half C and V. square, 50 square, that is 1.5 into 10 to the power minus 8 joule. Now moving to next, the stored energy, the stored battery of a car has EMF of 12 volt and the internal resistance of the battery is 0.4 q. What is the maximum current can be drawn from the battery? Maximum energy can be drawn from the battery. See, maximum energy I max, that is E upon R. E is 12 volt and internal resistance is 0.4 volt. So 12 upon 0.4, that is 30 ampere. That is 30 ampere. Right? 30 ampere. Okay. Now moving to next. A long straight wire in a horizontal plane carries a current of 50 ampere in north to south direction. In north to south direction. In north to south direction. In just like this. In north to south direction. North to south direction. Give the magnitude and direction of B at point 2.5 meter east from the point P here. P is here. Okay. So as you know, B equals to mu naught upon 2 pi I by A. B equals to mu naught upon 2 pi I by A. B equals to mu naught by 2 pi I by A. So using this, you can put the values. B equals to mu naught upon 4 pi 2 I by A, or you can say this 2 and 2 cancel, so mu naught upon 2 pi I by A. You have the value of I and A. 2 into 50 upon 2.5, that is 4 into 10 to the power minus 6 Tesla. Okay. Okay. And what is the direction? Using right hand thumb rule, tell the direction. See, what is the direction? What is the direction at point P? If I am using this law, curl rule, thumb indicating downward, so at P, outward from the paper, right? So direction is outward. Direction is outward. Yeah, these are 2 marker questions, so that these are easy questions. So don't worry. In your final examination, 2 marker question is the easiest one. Okay, fine. The peak voltage of an AC supply is 300 volt. What is the RMS voltage? As you know, Vrms is equals to V naught upon Vrms equals to V naught upon root 2. V naught upon root 2. Is it? V naught upon root 2. Okay. And you have 300. 300 is basically V naught. 300 is basically V naught. Similarly, the RMS value of current in AC circuit is 10 ampere. Here is given IRMS given, that is 10 ampere. That is 10 ampere. Okay. And peak value, that is asking I naught. Okay, asking this I naught. And the formula will be same. And the formula will be same formula. I naught upon root 2. You can use the formula I naught upon root 2. Okay, moving to next. Now moving to next. See, EV equals to E naught upon root 2, that is 300 upon root 2, that is 212.1, and I naught is root 2 times of IV, that is VRMS, root 2 times of 10, that is 14.14. Now, why is the sunglasses goggles which have curved surface do not have any power? Do not have any power. If curved glasses having power 0, that means the only situation P equals to P1 plus P2, first lens having the power is positive P and second one having negative P. So that P1 plus P2 is 0. You are using a concave and convex both lenses of the same power. If I am using concave and convex lenses with the same power, then the final power is 0. See, two lenses P dash equals to P1 plus P2. First one is P, second one is negative P. That means first one is convex and second one is concave. Okay. Now, light of wavelength 5000 angstrom falls on a plane of reflecting surface. What are the wavelength and frequency of the reflected light? For what angle of incidence is the reflected ray normal to incident ray? All right. We have x equals to 5000 angstrom. 5000 angstrom, that is 5000 into 10 to the power 10. 5000 into 10 to the power 10. But there is 3 zeros, so that compensate that this is 5 into 10 to the power minus 7. On reflection, no changes occurs in wavelength. Just remember, in reflection there will be no changes in wavelength. Only changes frequency and speed of incident light. Wavelength, frequency and speed of light never be changed in reflection, just because the light falls on the surface in the same medium and return back into the same medium, so that there will be no changes in frequency, speed or wavelength. But in refraction there will be change in speed, right? Okay. Wavelength of reflected light, that is 5000 angstrom, and speed of light is 3 into 10 to the power 8 meter per second. So V is what? C upon lambda. V is what? C upon lambda. C is 3 into 10 to the power 8 and this one is 5 into 10 to the power minus 7. 5 into 10 to the power minus 7. So that it will be 6 into 10 to the power 14 hertz. And this is reflected is equal to 45 degree. 45 degree. Okay. Yeah. Basically, see students, important questions are just important. So every publication mentioned that, every website mentioned that, and you already studied about these questions, all right? So important questions are just important. So moving to next. These questions are sure short questions for your examination. These are sure short questions for your examination. So don't worry guys, let's cover all these questions of 2 marker and 3 marker. I'm surely told you that these questions will be in your question paper also. Okay, these questions will be in question paper also, right? So moving to next. What is the ratio of radii of the orbits corresponding to the first excited state and ground state of hydrogen atom? As you know, radius is just r is directly proportional to n square. R is directly proportional to n square. Using this you can find the ratio. Okay, r is directly proportional to n square, right? So nth orbit, that is Rn, is directly proportional to n square. N equals to 1 to n equals to 2. Here is ground state to first excited state. Ground state to first excited state. That means n equals to 1 to n equals to 2. So that R2 upon R1 is what? N square, that is square of 2. 4 upon 1. 4 upon 1. 4 upon 1. Okay. 4 upon 1. 4 upon 1. Okay. Now moving to next. A PN photodiode is fabricated from a semiconductor with band gap 2.8 electron. Can it detect a wavelength of 6000 nanometer? PN photodiode fabricated of semiconductor of 2.8 electron volt. Is it possible? No. Vaishnavi, basically it's 4 upon 1. Second to first. They ask second to first. Okay. 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 EG spike, if these questions are covered in your handbook, in your sample papers, in your previous year questions, then obviously these questions will be in your final examination also. So don't worry about that. Okay, fine. Moving to next. Answer of this question. So answer of this question. See, lambda equals to 6000 nanometer, that is 600 into 10 to the power minus meter. Okay. Now check the energy level. Right. This is a photodiode. So check the energy level. E equals to hc by lambda. H is a Planck's constant. This H is a Planck's constant. C is the speed of light, and lambda given, that is 600 into 10 to the power minus 9. Now the value is 2.07 electron volt. As the energy associated with the wavelength less than the band gap energy of semiconductor, so can't detect wavelength. Here is energy gap of 2.8 electron volt, and I have the energy is 2.07 electron volt only. So this one is lesser than the band gap, so it can't detect. Okay, I'm not taking you much time, Aaron. I'm not taking you much time, just because I know you are preparing your syllabus as per your own way. So I'm not taking you much time. I'm just putting some questions which are short questions. So let it will be binded up to 60 minutes, right? 60 minutes. Okay. State 2 disadvantages of semiconductor device. 2 disadvantages of semiconductor device. What are the disadvantages? So first disadvantage is semiconductor devices are temperature sensitive. Even a small overheating may cause the damage of them, right? And second one, semiconductor device cannot handle as much power as ordinary vacuum tubes can, right? All right, these are the two most disadvantages. Yeah, Anita, you can download the PDF notes from the link given in the description box. Once completed the session, thereafter you can download the PDF notes from the link, right? Okay. Okay. And anyone if not subscribed the channel yet, just subscribe the channel and hit the bell icon also, right? Along with like the session and share with your friends also, right? These are most important questions. These are short questions. I repeat again and again, these are short questions, right? So I'm very much sure you remember me in your examination hall also. See, express the truth table of output Y, all possible inputs of A and B. If you are planning for the inputs A and B, then what is, see, here is A, putting here B, and what is Y? Y is basically C. This is A, B, and this is AND gate. So here, at this point, what will get? We get A dot B. Get A dot B. That is A dot B. And finally we'll get what it is. See, here comes A, and from here A dot B. So can I write A dot small y? This is the final. Just wait, just give me a minute. Just give me a minute. So So what is the final answer? A, that is 0101, B is 0011, Y is 000, 100, 010 and 111. Alright? Alright? Okay. Why FM signals less susceptible noise to than the AM signals? Okay. FM signals are less susceptible noise to AM signals just because FM transmission, the message signal is in the form of frequency variation of the carrier waves. During the modulation process, the noise get amplitude modulated since it brings about variation only in the amplitude of carrier waves. It does not harm to the message signal. For this reason, FM signals is less susceptible to noise than the AM signals. AM signals, that is amplitude modulated signal, and FM is basically frequency modulation. Frequency modulation is less susceptible to noise as compared to amplitude modulation. Okay. Now, the audio signal cannot be transmitted directly into the space. Why? See, there is a lot of reason. First one is audio signals having not as much power as we want to transmit one place to another. So that we use a carrier wave to transmit signal from one place to another. Second thing is there is a lot of noise, right? So the length of the antenna required so large, 500 meter, that particularly impossible to set up it. Second, energy radiated from the antenna, that is audio frequency range, is practically zero. The audio signals transmitted from the different broadcasting station get inseparably mixed up, right? Okay. Now coming to 3-marker question. Coming to 3-marker questions. And just subscribe the channel. Alright? Okay. Coming to 3-marker questions. Let's begin 3-marker questions. Okay. First questions. 3-marker first questions. Fill the blank choosing the appropriate answer given in the bracket for all the following questions. See, we have three options: real power, second is area of the loop, and third one is n lambda. These are the 3 options we have to put A, B, C. See, in Young's double slit experiment, the path difference for the constructive interference is equal to basically n lambda. This is basically n lambda. Second one, the power factor of AC circuit is given by the ratio of power factor, what it is? Real power. This is real power. And third one, the magnetic dipole moment of current loop is given by the product of current and the area of the loop. This is area of the loop, and this is power, a real power. This is a real power. This is a real power. Okay. Okay. Puspa, I think Shreyas sir was covered 100 MCQs. Already 100 MCQs covered. Alright. So, moving to next question. What is an equipotential surface? What will be the shape of equipotential surface corresponding to a single point charge? See, what is equipotential surface? A surface where the value of potential is equal at every point. Alright. And the second major thing, that is work done in equipotential surface will be 0. Just because what is potential difference? It is the work done in bringing a charge from one point to another. If 2 points having equal potential, then what is the difference of 2 points? That is 0. So that work done in equipotential surface always be 0. And what is the shape of equipotential surface? Equipotential surface is just like see. This is how showing equipotential surface. This is Q positive and electric field lines are outward. So this circular line, this circular curves shows the equipotential surface. Here the potential same, here the potential same. Just because you are finding V equals to KQ upon R. So each point, for this point, for this point, for this point, R is same, K is constant and Q is constant. But at this point, potential is different than the cost. Right? These are the different. So equipotential surface is this one. This circular path shows the equipotential surface, just because the deciding factor V equals to KQ upon R. R is the deciding factor for the equipotential surface. Okay. Okay. 3 capacitors each of 9 picofarad are connected in series. What is the total capacitor of the combination and what is the potential difference across each capacitor if the combination is connected to 120 volt? See, first one, as you know, in parallel plate capacitor, what is the value of equivalent capacitance? That is 1 upon C equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3. That is 3 upon 9 picofarad. 1 upon 9 plus 1 upon 9 plus 1 upon 9, that is 3 upon 9 picofarad. That is 3 upon 9 picofarad, right? 3 upon 9 into 10 to the power minus 12. 9 into 10 to the power minus 12. Alright, 3 cancel out. This minus 12 moving upward, then it will be 1 upon C, so that 3 into 10 to the power minus 12 picofarad, that is 3 picofarad. That is 3 picofarad. Okay. And if we want to calculate potential difference across each capacitor, then what it will be? See, as you know, in series combination, potential divides across the capacitors. So we have V1 plus V2 plus V3. And what is V1? V1 is Q upon C1. V2 is Q upon C2. V3 is Q upon C3. That is equals to 120. Q is what? See, Q upon 9 into 10 to the power minus 12. Q into 9 into, that is 3Q is equals to 120 into 9 into 10 to the power minus 12. That is 360 into 10 to the power minus 12. Why we calculating this? Just because potential difference, that is V equals to Q by C. V equals to Q upon C. Q is 360 into 10 to the power minus 12 and C is 9 into 10 to the power minus 12. Minus 12 minus 12 cancel out. 9 4s are 360. That is 40 volt. That is 40 volt. 40 volt. Okay. Yeah. You can download the PDF notes after completing this session. Alright. Okay. Okay. Once we completed the session, then after PDF notes uploaded, and you can download these questions from the link given below in the description box. Okay. Okay. Moving next. Don't worry, Preetham. Don't worry. State and explain Lenz's law of electromagnetic induction. Lenz's law. Basically, as you know, in electromagnetic induction, if we change the magnetic flux across a coil, then there will be induced electric current generated into the coil, and the direction of current in such a way so that they oppose the change in flux into the coil, or you can say change of the cause. So that E equals to negative d phi upon dt. As Faraday told, E equals to d phi by dt, but the negative sign shows it opposes the change of cause, right? Same like inertia, right? See, Lenz's law, the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. Induced current basically generated due to change in magnetic flux, and the current in the loop in such a way that they oppose the change, right? So Lenz's law, according with the conservation of energy, first, when the north pole of a bar magnet pushes towards to the coil, the current induced in the coil in the such direction. See, just remember, if north pole coming at to the end of the coil, then coil develop itself as a north pole, and if coil develop itself as a north pole, then the direction of current is anti-clockwise. If south pole coming towards to the coil, then it will be behaves like a south pole, and the direction of current is clockwise. And the direction of current is clockwise. Okay. A battery of 10 volt EMF and internal resistance 30 is connected to a resistor. See, internal resistance is always treating in the series combination with the same. Okay. If the current in the circuit is 0.5 ampere, what is the resistance of resistor? What is the terminal voltage of the battery when the circuit is closed? Right? All right. Okay. 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 Fine. Okay. Fine. See, there will be given E equals to 10 volt. All right. R, that is internal resistance, that is 3 ohm, and the current from it is 0.5 ampere. So, as we know, a current is the total EMF upon total resistance. This is total EMF upon total resistance. Total resistance, that means external resistance plus internal resistance. Now, we have to calculate R, that is E upon I minus R. E is 10, I is 0.5, and small r is 0.3, that is 17 ohm. That is 17 ohm. The terminal voltage of battery V equals to E minus IR. E is 10 and IR, that is 0.5 into 3, that is 8.5 is the terminal voltage of that battery. Okay? Okay? Okay. Okay. Moving to next. Okay. Sir, we are literally saying, Vikas, already we uploaded the session of 100 MCQs, right? CSL was taken that and already uploaded. Just go through that. Okay, I'm sure you haven't any doubt. Okay. Okay, fine. So till this question, everything is clear. Till this question, everything is clear. Or is there any interruption? Is there any problem with you? Okay, okay. I think everything is going good. Okay. Now, moving to next. Write a short note on TIR. Write a short note on TIR. What is TIR? This is total internal reflection. This is total internal reflection. See, in simple way, as you know, if light wave moving from denser to rarer, light wave moving from denser to rarer, okay, it away from the normal. Okay, if I increase the angle of incidence beyond the critical angle, then the refraction will become reflection. If the two key concepts for the TIR. First one is light wave always moving from denser to rarer, and the second one is angle of incidence is greater than the angle of angle of incidence is greater than the critical angle. So these are the two key concepts for TIR. Then refraction becomes reflection. Refraction becomes reflection. Okay? 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 Fine. Fine. So moving to next. Series LCR, R equals to 20 ohm, L equals to 1.5 Henry, and C equals to 35 microfarad is connected to a variable frequency, that is 200 volt AC supply. When the frequency of the supply equals to the natural frequency of the circuit, what is the average power transferred to the circuit in one complete cycle? For a one complete cycle. See, I have R, I have L, and I have C. Okay, let's calculate. Okay, let's calculate. See, L equals to 1.5 Henry, but C equals to 35 microfarad. Microfarad, that means 10 to the power minus 6 farad. That is 10 to the power minus 6 farad. And R equals to 20 ohm basically, not Q. This is 20 ohm. See, when the frequency supplied equals to the natural frequency of the circuit, the impedance of the circuit is equal to the resistance of the circuit. Therefore, RMS value of current that is IRMS is equals to E, matlab E VRMS upon R. This is VRMS upon R. VRMS, that is 200. This is the variable frequency upon 20, that is 10 ampere. 10 ampere is the current in the circuit. And what is the average power? P equals to VI. V, that is potential. Here we use that V as a EMF E. So P equals to EI. E is 100 and we already calculated current is 10. That means it will be 2000 watt. 2000 watt. 2000 watt. Moving to next. Two lenses of power 15 diopter and minus 5 diopter. Two lenses having power 15 diopter and minus 5 diopter. As you know, positive 15 diopter, that means it's convex lens. And negative 5 diopter, that means it's concave lens. This one is convex and this one is concave. Are connected in with each other, forming a combination of lens. What is the focal length? Focal length is positive of 10 diopter. Focal length is what? It's positive of 10 diopter. Everyone knows positive of 10 diopter. That means it behaves like a converging lens. It behaves like a converging lens. Behaves like a converging lens. The object of size 3 centimeter is placed at 30 centimeter from the combination of lens. Calculate the position size. See. If power equals to 10, then what is the value of F? F is basically 1 upon P. 1 upon P. That means it is 1 upon 10. Alright, it is 1 upon 10. Okay, this is in meter. This is in meter. So in centimeter, this is basically 100 centimeter. 100 upon 10, that is 10 centimeter. So you have F equals to positive of 10 centimeter. You have U equals to see, U equals to 30 centimeter, which is negative of 30 centimeter. As you know, U is always be negative. U equals to negative of 30 centimeter. Calculate the position, that is calculate V, and you also calculate height of image. This one is very important question and very easy questions too. Very important and very easy. So power is 10 diopter. Now using U equals to minus 30 minus 1 upon U plus 1 upon V equals to 1 upon F. That is V equals to 15 centimeter. V equals to 15 centimeter. V equals to 15 centimeter. And what is magnification? Magnification equals to F upon U plus V. So 10 upon minus 30 plus 10, that is negative of 1. So size is minus of 1.5 centimeter, which is inverted, which is real. Negative, that means inverted, and inverted, that means it's real. It's real. Negative and it's real. Okay. Which circuit diagram explain how can galvanometer converted into a meter? Right. Someone asked this question yesterday in a doubt. See, if you want to convert galvanometer as a ammeter, then you are using a low resistive shunt in parallel with the galvanometer. This is a galvanometer, and this is a shunt resistance parallel with galvanometer, having the resistance of Ig upon I minus Ig. This is the resistance with the minimum value, so that you want current moving through this shunt. Okay. Write the truth table for the given figure. See, if there is A and there is B, what it Y equals to A plus B bar. Here is Y equals to A plus B bar. Here is Y equals to A plus B bar. A plus B bar. And again giving these inputs to another NOR gate, right? Then what is the final output? The final output is Y equals to A plus, just because if you are using double bar, that means it's a simple value, right? State and explain Heisenberg's principle. State and explain Heisenberg's principle. Okay, Heisenberg principle. See, Heisenberg's principle, what it is? Each point on wavefront is a source of secondary disturbance, and the secondary wavelets originating from these points separated out in all direction with the speed of the wave. And second one, the new wavefront at any later time is obtained by taking the tangential surface in the forward direction to all the shapes of secondary wavelets. Alright, this is Heisenberg's principle. Alright, see, if I'm taking a line along with this line shows the direction of secondary wavelets. These lines shows the direction of secondary wavelets. Okay? Derive the expression for electric field due to infinitely long straight charge wire using Gauss law. Using Gauss law. Okay. Just consider this is a current carrying conductor, and around this I'm just taking a Gaussian surface. This is a Gaussian surface, as you know, everyone. This is Gaussian surface. If charges on this conductor is positive, then we have three slots. First one consider as ds1. This one considered as ds1. Here, the direction of electric field intensity in this way, and direction of surface vector is just like this. Similarly, here also electric field intensity in this way and direction of area vector in this way, but at the third position the direction of electric field intensity and the direction of the area vector both are parallel. So here flux will be 0, here also flux will be 0, here only the flux available, that is phi equals to E ds. ds is 2 pi RL, right? E into 2 pi RL, which is equals to phi. And using Gauss theorem, you have phi equals to 1 upon epsilon naught times of q upon epsilon naught, right? Just put q equals to how much? Q equals to lambda L. Putting this value, phi equals to lambda L upon epsilon. Just comparing these two, phi and phi, just comparing these two, you get E equals to lambda upon 2 pi epsilon naught times of R. lambda upon 2 pi epsilon naught times of r. Okay? Okay. Yeah, obviously these are most repeated questions. So derive the expression for the de Broglie wavelengths of an electron accelerated through the potential difference V. See, first kinetic energy is EV. Second one, momentum is P equals to under root of 2m EK or KE. K is the kinetic energy. That is, kinetic energy is EV under root of 2m EV. P equals to 2m EV. P equals to 2m EV. Third step is what? Lambda equals to H upon P. H upon P. P is 2m EV. P equals to under root of 2m EV. So lambda equals to H upon under root of 2m EV. H upon under root of 2m EV. State and explain of Gauss theorem. State and explain of Gauss theorem. Okay, state and explain of Gauss theorem. What Gauss theorem says? According to Gauss, if there will be a charge, just consider a symmetrical Gaussian surface. Consider a symmetrical Gaussian surface. Then the total number of flux emerges from this Gaussian surface is 1 upon epsilon naught times of Q. Total charge present inside the vessel, right? See, the total flux through any closed surface is equal to 1 upon epsilon naught times of the total charge enclosed by the surface. That is, Q enclosed, or Q is the total charge, the Gaussian surface, then the electric flux is 1 upon epsilon naught times of Q. All right. I know everyone knows the derivation of the Gaussian theorem. All right. Okay, next. Give the difference between p-type and n-type. See, in p-type semiconductor doped by trivalent impurities. In n-type, there will be pentavalent impurities. And in p-type, holes are majority charge carriers. In n-type, electrons are majority charge carriers. Electrons is minority charge carriers in p-type, whereas holes is minority charge carriers in n-type. And impurity of atoms called acceptors, that is indium, aluminium, boron, gallium in p-type, whereas phosphorus, bismuth, antimony, these are impurities to making n-type semiconductor. Electrical conductivity relatively less and electrical conductivity relatively more. Okay. Okay. So these are 2 marker and 3 marker questions. These are 2 marker and 3 marker questions, right? And these are most important questions. So we will meet in another session with some more questions, which are short questions for your examination. Till then, you can solve your sample papers. You can try to learn all these formulas and all these questions once again, so that you can surely get 70 out of 70 in your PU second examination. So just like the session and subscribe the channel and share with your friends. We'll meet in another session. Till that, bye bye. Take care, everyone. Thank you so much.